Okay, let's look at this interesting logarithmic equation here. So we have 6 times log 2 to the base x minus 3 times log 3 to the base x equals 3 times log 0.2 to the base 5. So, but let's first resolve these numbers that are in product with the log. That's your 6, your 3, and this 3. So of course, you know, in the laws of logarithm solution, your 6 moves and becomes a power of the number 2. So it now becomes log 2 raised to the power 6, still your base x. So the 6 becomes a power for 2, and that's it here. Minus, the same thing happens, this 3 becomes a power for this 3 here. So you now have log 3 into raised to the power 3. So this 3 becomes a power. So this 3, I have it here now, and this 6, I have it here now. Equals, the base x, then equals, the 3 becomes a power for 0.2 also. So you now have log 3 is no longer here, it is now a power for 0.2, all raised to power 3. Then you still put your base 5. So the next thing is to try and convert this 0.2 to fraction. So convert the 0.2 to fraction. So you have 0.2. Of course, you know how to convert to fraction. Rule a line, write 1, then check how many digits you have after the point. I have just 1 digit and it's 2, so I'll add 1 0 here. Remember, if there are 2 digits after the point, I'm putting 2 zeros, but because it's just 1 digit 2, I'm adding 1 0. So I have 2 over 10 as my value. So if I have 2 over 10, I can still simplify 2 over 10. I can still reduce further to its lowest term. What can divide 2 and 10? 2 can divide 2 here, 1. 2 in 10 is 5. So I have 1 over 5 as the fractional form of 0.2. So I'll replace this 0.2 here with 1 over 5. So I'll then have, still write out my log 2 raised to power 6 base x minus log 3 raised to power 3 base x equals log 0.2 is now 1.5. 0.2 has been changed to 1 over 5 rather. So 0.2 has been changed to 1 over 5. So I have 1 over 5 all raised to power 3, then put my base 5. So it's looking okay now. So what I will try to do here is, I notice this one, I can easily evaluate this logarithmic expression on the right hand side because there's no unknown there. I just have log of 1 over 5 all to the power of 3 base 5. I can evaluate this and get a value for it. So let me go to my rock paper and do the same thing. So I'm going to evaluate this one separately and find an answer to it. So log of 1 over 5 all power of 3 base 5. So how do you evaluate this? So you ask yourself, 5 raised to power what will give me the number? That's the question. The base raised to power what value gives me the number of the log. So let that power that you don't know be x. So that's how to evaluate this. So 5 raised to power what? Since you don't know the power, let it be x. So I've written it here. So 5 raised by x will give me this. That's the idea. The base raised to power my result here gives me the number here. So 5 raised by what will give me this. So that's 5 raised by x equals 1 over 5 raised to power 3. So law of indices, I can reverse the 1 over 5. I now have 5 raised to power x equals 5 raised to power minus 1 in the bracket. Then I have my 3 still outside. Then I'll have to open the bracket by multiplying the 3 outside the bracket and the minus 1 in the bracket. So I have 5 raised to power x equals 3 times minus 1 is minus 3. So I have 5 raised to power minus 3. Then the 5, the bases can go, leaving my power as my main number now. So x equals minus 3. So after evaluating this, I got minus 3. That is to say, I'm going to replace every of these with minus 3 that I just got. So rewrite this again. I'll have log 2 raised to the power 6 base x minus log 3 raised to the power 3 base x equals minus 3, because I evaluated this and I got minus 3. So you know the rule. I'm going to pick one base. Since the bases are the same, pick one of the bases, log base x, and then I will divide the numbers 2 raised to the power 6 and 3 raised to the power 3 because of the minus sign. That's one law, one of the laws of logarithm. So that will be 2 raised to the power 6 divided by 3 raised to the power 3, then equals minus 3. And of course we know that 2 raised to the power 6 is what? That is 2 into 6 places. That's 2 times 2 times 2 times 2. That's 2 times 2 times 2 times 2 times 2 times 2 in 6 places, and that will give me 64. So I have log of 64 over 3 raised to the power 3 is 3 times 3 times 3, and that's 27 base x equals minus 3. And of course we know the base raised to the power what? Raised to the power this value must give me the number here. That's one of the laws. The base raised to the power this must give me the number. So that's x raised to the power minus 3 must give me 64 over 27. So I'm going to reverse this using law of indices. I will now have 1 over x raised to the power 3 equals 64 over 27. Then I have, if I now cross multiply, I'll have 64 times x raised to the power 3. I have 64x raised to the power 3 equals 27 times 1 is 27. Then divide both sides by 64. So 64 cancels 64. My x is now finally 27 over 64. My x raised to the power 3 rather. 3 is still there. Then of course the power will leave here and become a power for the whole values here. So 3 will leave here and become a power for this value, and it will become 1 over 3 when it comes here. Like I said before, it always inverts. The powers will always invert. So now I have the x will now be free. The 3 is no longer there again. It has moved to become 1 over 3 here. So it will now become, yes, any number raised to the power 1 over 3 is the cube root of the number you're going to find. So now put your root sign. The 3 stays here. Then you have 27 over 64 powered the 1. So x equals, what's the cube root of 27? Is 3. And the cube root of 64, that means you are looking for a number you multiply 3 times to get 64, and that is 4. All powered 1 is still, any number raised by 1 still gives you the same thing. So x equals 3 over 4. So that's it, very simple.